Thank you for coming to our presentation. How many of you were here for the presentation that we did yesterday? Okay. Small amount, actually, like 20% of the room. So we're going to cover a few things. You guys are not going to be too bored, I promise. We're going to do this presentation is slightly different because it focuses more on the best practices of how to do things from a very practical standpoint. Of course, lawyer talk. We're not lawyers, but they tell us to say this, right? If you try any of this, can burn your computer and so on. The agenda that we're going to cover, we're going to do a quick 101. We're not going to do as much as we did yesterday. We're going to do a one-slider 101. The assumption is that if you were here in the presentation that we did before, you already went through the 101, and if not, you can watch the videos, right?
I think it's 11:42.
Right. And we're going to do also 101 on Kubernetes, and then we're going to focus on the operational aspects of things, right? We're going to do an architecture for containers 101, then network and security controls in more details, best practices that we have learned through doing things. Merlin and I have done quite a bit of actual hands-on deployment for paying customers. And we're going to focus also on monitoring and logging and platform as code, which is extremely important, the BOSH section as well, right? Understanding how BOSH works, what is really BOSH underneath. And then finally, how will it look like when you have PKS and PCF together, which we anticipate that a lot of the deployments you're going to see in the next year are going to have a little bit of both. So that's, or separate, right? They're not mandatory together. They're loosely coupled products, but when they're together, they actually have quite a bit of power.
We're going to apologize, too, because there is a lot of content, and we're going to fly through it, hopefully. The intent is so that after the session, you guys actually have this content as a takeaway when you download. Right. My apologies, we put too much in there.
So, real quick again, developers, platform. Right? This is the typical thing that we go through when we talk about the Cloud Foundry 101. Developers only care about this. Here's my source code, run it on the cloud for me, I do not care how. If you have ever talked to corporate developers, that's actually what they want. They really don't care about your fancy networks or your fancy computers, anything like that. They don't care. They just want to push their code, right? So the platform actually take care primarily of this, right? That's the whole purpose of this entire thing. They code in whatever they do, editors, IDEs, you name it. They push their code into Git repos traditionally, either internal-based Git repos like GitLab or things like that, right? Or your own open source Git, or external ones like GitHub or GitHub Enterprise as well, right? And then, from then, the code gets picked up by a robot. When we say a robot, we're talking about the CI/CD cycles, right? The CI/CD process. That's your Jenkins, that's your Concourse, tools like that. Those are the ones that grab code, they detect that there was a change there, and they do this magical thing that we call generate an artifact, right? This artifact in our example here is a Word file. We're assuming that the example is a Java type application. It does not have by any means to be Java. It can be any language. Cloud Foundry is a polyglot platform, so it will allow you to support basically any language. We have several languages out of the box. There's a few other ones that can be added as open source as well. So a CF push is the command that actually is executed, and it pushes the code directly after authentication, of course, into the platform itself. Once the code gets inside of the platform, goes through a staging process. The staging process actually has two pieces, right? The important part is the build pack process. Build pack understands the code, looks at your code. You don't even have to tell the platform what language this is written on. The system will detect that automatically. There's a detection phase in the build pack process. The build pack then will download all the dependencies that are required to build your artifact for your code. So if you're, for example, a Node.js application, they will do an NPM, they will download all the pieces that you need from internal repositories or external repositories. This can be completely isolated from the internet. It doesn't have to be internet bound, but if you do, then you can also use that. The important part, in my opinion, here is this rootfs piece. This is an extremely important piece of the puzzle here. This is a curated file system that we produce at Pivotal, and we pass it through all sort of scanning processes. Every piece of code that we produce in Pivotal is actually scanned every 6 hours, right? So we actually take care that there is known vulnerabilities in the artifacts that we ship. Why is this important? Because the developer doesn't have to care about all those details. In the Docker workflow type things, you actually do care about that. I mean, you own the entire artifact that is your container. In this workflow, you don't care about those components. The platform takes care of those components for you. So there is no ownership involved in the process. This is extremely comfortable for a developer. They don't have to worry that 2 years later somebody's going to knock at your door and say, hey, there's a CVE in the code you did. Right? So then this gets merged into your final artifact that we call a droplet. In the Docker ecosystem, the droplet is typically the equivalent of your Docker image, right? To give you a sense. Now this artifact now resides in the blob store and it gets deployed depending on how many application instances that we call AIs here, how many applications instances are you going to deploy across the different availability zones. AZs are typically mapped to your failure domain. Your failure domain in a vSphere world tends to be primarily a cluster. They can be resource pool as well, but they can be typically clusters for production environments. So your application typically has a wildcard domain, and in this case foo.com, and has a name for the app. The app is called my app in this case, right? So typically the NSX Edge VIP is pointing to a wildcard domain called foo.com all the way up there. The DNS is resolving to the VIP. You have an NSX Edge there that is acting as a load balancer. Then it's sending it to the routing tier. This is not layer 3 routing. This is layer 7 routing, right? This is a reverse proxy mechanism, right? From then, the request goes to the app itself. The app has a name, right? The system will determine the name, will map it to the next available instance, and will send it to the proper application instance to respond to whatever the application is actually doing, right? All this, again, happens automagically in the background without the developer having to worry about any of this stuff. The developer doesn't worry about the Nginx configuration or anything like that. All that is taken care of by the entire platform in conjunction with NSX. If for any reason you want to push your entire Docker container, you can also do that. You just send it directly. There is no build pack process. There's no staging. It works the same way. There's a few restrictions. You cannot export UDP ports and things like that. But in addition to that, it works the same way. It can also stage Docker containers. So again, Polyglot platform supports a number of different languages. These are the ones that we support in the bottom there. By out of the box, there's many others, and there's plenty more to say about this. Let's talk about Kubernetes now, the one-on-one piece.
Yeah. So let me ask you a couple of questions so I can hopefully drill in and go faster and talk about the right stuff. Show of hands, how many people in this room have actually deployed Cloud Foundry? Wow. So this is a lot of like, what is this? Okay. How many people have actually deployed Kubernetes?
Less than Cloud Foundry. Wow.
I guess it would be reaching if I said how many people actually run a CF push or a kubectl command. How many people actually push to those? Okay. So we're probably going to be doing some mind-numbing stuff here.
Yeah.
We're kind of digging deep in architecture. What you just saw Ramiro go through with Pivotal Cloud Foundry, that's all running on top of vSphere infrastructure. Those are VMs that are created to run your containers, your applications. I guess by show of hands, who knows what a container is? All right, so at least most of us know a container. So we got a good base to start with. Okay, so where Kubernetes is slightly different. This is a representation of a Kubernetes cluster, right? And PKS, which we announced here at VMworld, when we announced initially in Las Vegas and we re-announced here. We're implementing these components of Kubernetes, master, API servers and etcd and worker nodes as VMs. So we're instantiating them as VMs. But the developer still sees a Kubernetes API. That's the important thing. Is what is the developer getting? They're not getting a set of VMs or anything like that. They're getting an API and services with their API. So just like we saw in Cloud Foundry, a developer would check their code into a code repository, have a pipeline execute on that commit. But instead of actually putting an artifact that would say be like a WAR file, I still have to generate that WAR file. I still have to make my application code, or if I'm doing a Node.js app, I still have to run a config check on it, whatever my app platform is. But I also now have to take the burden of building the image. We saw that droplet process in PCF. We don't do that with Kubernetes because Kubernetes is running Docker in the back end, and we're giving it an image. We're telling it, this is the image that I have built. Either the developer builds it by hand, or in most cases in the real world, they're building it with a CI/CD pipeline. So here we see that it's checked it into a registry. What a registry is, it's like a library of a bunch of Docker containers. And wow, I did that one backwards. I guess the animation should have been on the front. So what happens then is when that pipeline says Kubernetes run this application for me, it's going to go out to our library, our Docker registry, and pull the images that we've defined and run our applications. What's going to be a little different now is how do we get access? So if I've got an application like myapp.foo.com and K8 is cool running in one of these pods that we just deployed, in pods, raise your hand if you know what a pod is, so I can know if I got to dig into that or not. So about half of you. So a Docker image gets instantiated as a container in Kubernetes. So like if you did a Docker run, that's what these containers are. A pod is a collection of one or more containers in Kubernetes. It's a Kubernetes construct. It's a logical collection of one or more containers that share a common network space. In our application, we just deployed it across 2 pods. We just made sure that this application, myapp.foo.com, has 2 instances or 2 replica sets so that if one of these worker nodes goes down, the other one can still respond. Anyway, to get my routing request in, I don't have that fancy routing layer like we have in Elastic Runtime and PCF. So I actually have to tell, the developer has to actually tell Kubernetes, hey, I'm going to expose something called a service. This is how I want you to come into Kubernetes to access this application or this service that I've just deployed inside of Kubernetes. And then, we have to do some routing to get to it and get our routing request to the pod. So the key differences here to call out with this is Kubernetes depends on me to build the image externally, which is great if I want to control the image. It makes it hard to do things like CV scanning and patching. But in addition, it has me do some additional things. It doesn't make all the decisions for me like PCF does on the PCF platform. So the reason we covered both of these is when you want to architect for containers, you want to understand what your developer community needs to be agile. You as the operator, I'm going to assume based on the low number of hands we had of like installs and like we don't have many developers here, we're all vSphere guys, probably operators. You as the operator are typically going to be tasked to make sure your platform is available and that you're giving the developers what they need to be self-service and agile. So what you want to do is you want to give them the right abstractions. You want to give them things like the right API for the right type of application that they're developing. Some apps are going to be better suited for Kubernetes, depending on the control and the design of the app, and some apps are going to be, some app dev processes will actually be better suited to Cloud Foundry. So it's a matter of understanding which one of your developers needs and make sure that you provide it for them. And as always, build for failure. Your application is going to have resiliency into it, or you hope that your application has resiliency design. Your platform is going to have resiliency design, and you want to have your physical infrastructure have resiliency design. So how do we do some of those things? We'll start from the PCF side first, and we'll kind of take a look at Kubernetes. So as a platform operator, I'm going to be someone who owns, or at least has policy to control the physical infrastructure and set the physical infrastructure up in such a way that I can deploy Cloud Foundry. Cloud Foundry is deployed, it's not as simple as that Kubernetes image we just looked at a minute ago. Cloud Foundry has all these different VMs, Go routers, UAA for user access and authentication, Diego Brains, Loggergators. There's tons of moving parts. I think there's like 22, 24 core jobs right now in the current release of ERT, and you'd have multiple instances of those. What you want to do is you want to make sure that you're having those services be available. For example, if you look at this list of VM, and all these white boxes are VMs in a Cloud Foundry implementation, UAA is how I authenticate to Cloud Foundry. If I didn't have multiple iterations of UAA across multiple physical fault domains, I might suffer a failure. I might architect a single port of failure in my deployment. So this is why you see multiple availability zones in typical PCF architecture, and usually those availability zones map to resource pools. Clusters, so you can have physical fault domains and you'll have resources.
There's one note on this, which actually is very interesting too, is the fact that by having more than one of these elements, you can actually do a rolling update of the entire platform while it's running without losing any sort of functionality. So that's a key component of Cloud Foundry, and now obviously for PKS as well, thanks to the substrate that we have underneath, which is BOSH, that we're going to talk later about.
That's a good point, man. And you can see here in the imagery that we have something called BOSH, which is connecting to our vSphere infrastructure. And that in the animation that kind of deployed our Cloud Foundry instance. To deploy Cloud Foundry, you deploy something called Ops Manager, which is delivered as an OVA, we should all be familiar with. And you configure it and tell it how you want your Cloud Foundry instance to look, and it deploys something called BOSH, which deploys Cloud Foundry and maintains the health of it. The developer, though, like this is the operator. This is the operator's view of, hey, I'm giving this Cloud Foundry API or this Cloud Foundry space so my developers can be agile with their, with their CI/CD pipelines. This is what I see. The developer logs in through the API and just sees these logical constructs of orgs and spaces. The developer shouldn't be concerned of what's happening down here in the underpinnings. A developer should never need to know, do you have three etcd hosts across the three AZs to make sure you can maintain quorum? A developer should never need to know that. They should just need to know my API is up, the services and logical constructs I need for my applications are up and functional. But me as the operator, I need to know these things so that when these applications are running, if I suffer a failure inside of a particular AZ, like we say we'd have a 3-host cluster here inside of an AZ, if I suffer a host failure, I want to have things like vSphere HA turned on so that I can get those VMs to recover quickly, get them to recover on a different host inside of the cluster. Additionally, what if something happens inside of the guest that a vSphere HA event can't recover? Bosch has Bosch agents in all of these VMs, so Bosch will kind of monitor them too and make sure that they're healthy and rebuild them when there's a fault with them. So it's kind of a dual purpose thing. You know, I want to make sure the platform's already kind of keeping itself healthy, but I want to additionally bolster it some of the vSphere basic fundamental high availability constructs that I can. And the health monitor is the component inside of Bosch that would actually help rebuild that VM.
Bosch is actually at all times, Bosch is constantly checking what is called desired state versus current state at all times. So it always tries to make sure that the desired state is the one that is actually running. If there's any drift or any variation, Bosch will not go and try to fix anything. Typically declares the process down, the process gone. If it tries to restart that, if the process doesn't restart, it wipes out the VM and just put a new one in. Yeah. It doesn't care about going inside and fixing things.
Nuke it. Okay. So another concept with Cloud Foundry, and we'll get into Kubernetes and PKS in a minute, is singleton jobs. There are some jobs in Cloud Foundry that there's only just one copy of, like Bosch itself. You know, the way PCF deploys it, it's just one VM. So as an operator, I want to make sure that I architect ways that I can recover these things and make sure that availability stays up. There's a special job called the blob store in PCF. If you guys remember the Kubernetes Blue 101 slide, where it had the Harbor registry, like the image got put inside of a Harbor registry. Well, that staging process that Ramiro went over on the green slide, it's like a registry. The blob store is like a registry for the droplet in PCF. But PCF, by default, only kind of gives me that in one VM, which is kind of like a SPOF. So typically what you want to do is put that into a compliant external system like an S3 store so that you can have some sort of resiliency on your blob store. Get rid of your singleton jobs by either moving them to external services or making sure that you put some sort of a good DR plan into recovering them. Multi-tenancy. So again, we're still on PCF, not PKS yet. The term we use at Pivotal, or I should say, I'm not we, they're Pivotal anymore, I'm former Pivotal. The term we used to use at Pivotal is foundations. That's like an implementation of Cloud Foundry. You typically have more than one foundation because sometimes you might have like your app dev teams want to have a network zone that their production containers are running in, but they want to develop on the same platform that they're doing their dev and UAT cycling. So you might have another complete foundation that's in a different set of network isolation zone that's more permissive for development, and then the same application is pushed and moved over into production. So in a lot of use cases, you'll get multiple foundations. And it's a good best practice to use resource pools in that way so that you can do some, if you're going to share infrastructure, like in this example, we have a common set of clusters that we're running more than one foundation on. Then we can use things like ACLs and quotas, like different CPI user IDs for different resource pool sets and different limits per each foundation. Recovering the platform. So I say this sometimes. Sometimes you want your platform to be a pet. I always use the pets and cattle analogy. I know some people might not think that's the right analogy, maybe him. Your applications that you're running, you definitely want those to be cattle, meaning that they can be terminated and relaunched at any time. You're operating or you're keeping care of them in a herd, in most of them. But your platform by which the developers are pushing these to, sometimes you want them to be pets because you don't want to interrupt service. You don't want to interrupt the CI/CD pipeline at any point in time. So we're going to make sure that you can recover a Pivotal Cloud Foundry deployment as quickly as possible. And that, one of the hidden things we have happening here is we're going to talk about something called platform as code that I'm kind of going back and forth here. And what this blue image is an automation pipeline. And it's a concept of pipelining your platform in addition to your applications, treating your platform as a piece of code too, to where it's declarative and you can just rebuild it if you have to as quickly as possible. You don't want to because it's a pet, but if you have to, You want to be able to get it up as quickly as possible. So you want it to be deployed and managed in an automated manner. So that's why we have the automation through a pipeline driving and redeploying our foundation. That's one approach to recovering a platform. Additionally, you might have data, right? So great, I can reinstall or, I could redeploy my platform because I defined it as code, but what about all those running apps and droplets that I might have had predefined already, or if I had any persistent data? You got to understand where the data points are inside of a running foundation. For control plane data, which is what we're showing here, like some of the databases inside of Cloud Foundry. But additionally, you want to make sure if you're managing services with BOSH and you're using, even if you're not managing services with BOSH, if you have external data services, you use the operator still have to plan where's my persistent data at and how am I doing a backup job for my persistent data? Because at some point, almost all cloud-native applications will have persistent data somewhere. They may not be running in the Kubernetes clusters, they may not be running in PCF, but the data is going to be somewhere, and you have to be mindful of that for the complete picture. So vMotion, this is just a couple other vSphere fundamentals. When you're running Cloud Foundry or PKS on top of vSphere, vMotion is a good thing. It balances all these VMs, all these different workloads evenly across our clusters. We want to do that. Storage vMotion is a bad thing. And that's a BOSH limitation. The reason for that is because when a vMotion event occurs, VM decays. So these VMs, BOSH can rebuild a VM like we mentioned earlier when one of our VMs failed. I think it was our loggregator and it rebuilt it, or our cell server. There's a concept of persistent disk and ephemeral disk. Persistent disks have our state. Ephemeral disks can be destroyed. They're just there for temporary storage. They can be destroyed and rebuilt. So when BOSH rebuilds a VM, it detaches our persistent disk, rebuilds everything else from scratch, brand new, and then reattaches that persistent disk so that's how it can maintain data. The problem is a vMotion event actually renames the path of that persistent disk when a storage vMotion event, not a vMotion. A storage vMotion event renames that path when it goes to its new target data store, and BOSH doesn't react to that cleanly. So it takes a manual operator intervention at that point to repair it. So it can be recovered, but it's not something that's a best practice. So for all you vSphere guys, when you're looking at running Cloud Foundry or PKS, storage vMotion may not be something you want to enable at the get-go. Multi-sites. Hey, how about forget about having multiple foundations for different life cycle. I want to have multiple foundations for geo availability or BCDR. One of the well-documented and probably mature patterns that we have with multiple Cloud Foundry, and the same pattern could actually be leveraged with PKS, with Kubernetes in the back end, is to use GSLB, global server load balancing. In which case you have health checks probing, or one of those sites open. If one of the sites fails, I'm just going to route traffic to the other remaining site. So it's we have actually, I think it was Adam's Wiki's team out in at Pivotal. Yeah. They've written actually a nice white paper on how to do Cloud Foundry with GSLB. Yeah,
there's a very good paper that just got published on this and the best practices for that.
Okay, I just did a lot of stuff about PCF, which I guess is good because hardly none of you guys knew about PCF. Now I'm going to throw PKS up at you, which is that Kubernetes thing we were talking about. This is what we've announced with Pivotal, so it's another joint, or this is a joint product, Pivotal, whereas PCF is just something we jointly deliver and build integrations around. Notice that BOSH piece. If you've seen this image here at VMworld, this BOSH piece is really part of the key of how we're going to operate and deliver PKS at scale. What does BOSH do? BOSH does a lot. BOSH deploys Kubernetes. Kubernetes is actually delivered, so PKS is got two key open source components to it. One of those being BOSH, which we've just kind of gone over BOSH quite a few slides, and the other being Kubo. Kubo is an actual release, so it's a tarball of the Kubernetes software that you would hand over to BOSH and then have BOSH you would declare to BOSH via these manifest files how you want the Kubernetes clusters to be deployed, aka we have a Team A and a Team B manifest here. And then BOSH would just make those Kubernetes clusters exist for us and maintain the health of them, just like we would do with PCF. One of the things I do want to call out here is even though we're sharing a common automation engine with BOSH, PKS does not require PCF. So it means if you want to give your developers a Kubernetes API and you don't want to go through all the hassle of the large architecture that we just saw of PCF, you just want a lighter weight PKS architecture or Kubernetes architecture. PKS can run independently of PCF. It's not a requirement for both of them to run together. And multi-site GSLB can be accomplished in much the same way we just saw with PCF. So this is, we're going to, like I said, we're going to roll through some of these slides. All these things, when you hear the term developer-ready infrastructure at VMware, or at VMworld, developer-ready infrastructure is not referring to Cloud Foundry, and it's not referring to Kubernetes in particular. It's referring to the technologies that we're putting together to deliver those APIs to the developers, to get the developers ready online quickly and give the operators the tools they need to deliver it. And so it actually includes both PKS and PCF, which is why we're talking about both of them in this presentation. So now I'm going to hand over to Ramiro, and he's going to blow your minds with network security deep dives on networking with Cloud Foundry.
Now, actually, the networking in Cloud Foundry is fairly generic, actually, but it becomes more interesting when we leverage things like NSX with this, right? Because NSX gives a lot of abstractions that are very useful for Cloud Foundry in particular. In a typical Cloud Foundry deployment, what you see here is several different logical switches. And my assumption is that this is all based on NSX technology. You can do this with physical switches and VLANs and so on, but you're going to have to do some hard keyboard work.
Raise your hand if you know what a logical switch is.
It's a good portion, yeah. There's been a lot of talking about NSX in the show, but in general, you can do these things with physical switches and VLANs, but it's much, much harder to do and takes manual consistency to do, across all these sites. So NSX helps a lot in cleaning this up and making it all very easy to automate. So what you see here is basically an infrastructure logical switch where you typically have all your components like Bosch or vCenter, the ones that are really controlling the entire system. Then you have the elastic runtime, everything that we talked about before that has the routing tier, that has the Diego tier, and all this brain and all these components that are living within Cloud Foundry itself. And then you have the services, which are typically separate entities like RabbitMQ or MySQL or Redis or things that the developers are going to consume and use, right? They typically reside within their own logical switches. You don't have to. Some customers use that single logical switch for all the services. Some of them like to separate per service. There's no specific recipe for that. We tend to adapt to whatever you guys need in particular. The interesting thing is that if you peel the onion here, if you see what's really underneath, you're going to see that we expose 3 different VIPs on the access to Cloud Foundry itself. One is for the apps themselves, right? The apps needs to be accessed from the outside, right? So you typically get a domain like foo.com, for example. Those apps are going to come through that domain. They want to go inside the Go routers. They're going to end up landing in one of these cells. In addition to that, you want to give developers access to SSH so they can SSH to their containers if there is something to troubleshoot. We do not turn this on in production ever, right? This is for typical development environments where you traditionally are doing that. There's also TCP routing. This is more for non-HTTP type applications. Let's say you have a IoT application that uses the MQTT protocol, for example, right? A device that is broadcasting data every couple of minutes. That information comes via typically a TCP port directly. So the TCP router is a separate entity from the Go router traditionally. And all that gets also sent to the proper device in the system, right? The other aspect, which is a really good best practice, is whenever you're going to do a deployment like this, the very first thing you need to do is talk to your network admins and make sure that you get your wildcard certs and DNS approves ahead of time. This is a real pain for a lot of people out there. Because number one, in most companies, they're not used to see wildcard certs, right? So that tends to be a discussion to have with the security teams. They are typically not very friendly about that concept. They're not used to it, right? So it needs time for explaining and educating what does it mean really to have wildcard certs. There's not only one, there's a second one as you see here, right? You can have app level wildcard certs as well as other ones that are related to the internals of the platform only, right? But you need to have them ahead of time. You need to have the VIP associated with your NSX edge, and that needs to be resolvable. To those wildcard names needs to be resolvable to that VIP in particular, so you can send traffic to Cloud Foundry. Every traffic that goes into Cloud Foundry goes from the north. There's no other way to talk to the platform. You always come through the load balancer, right? That's your entry point. That's why it's so important that this is properly set up ahead of time before you start doing even the installation of Cloud Foundry. So this is your application, right? The myapp.defaultapps.foo.com. It goes all the way in. It gets routed properly through the app layer, and then it lands in one of the cells that is running that application instance. Obviously, you want to have more than one application instance of your application. If you have only one, you're running the risk that that cell may die or anything like that happen, and then you lose the access to your application and you get a nasty 404, right? So in addition to that, there's a number of other things that NSX will provide to you, right? Specifically is the access to the services, right? The logical switches that are provisioned by, that are typically used to land services are very important that they are typically separated. So you can create ASG rules, what they are called application security group rules, so you can explicitly state access to your services. Within Cloud Foundry, there are some logical constructs that do not map to anything physical in the real world. Things like organizations. They don't map to anything physical. Or spaces. What is a space? It's a logical construct, right? A developer can have a space, or multiple developer teams can actually have a space, or a small team can have a space. So you put rules around those spaces, and you say, I want my space to be able to talk only to these services in particular, right? Those are your ASG. They're outbound rules, right? They get set up properly there, and they get access to the external system. So you need to use multiple NSX logical switches and subnets. Typically one per deployment is your best practice, so you can be more granular and see exactly who needs to access what. Not every space needs to access every service, right? You want to be granular about that. The usage of ASGs typically occur and is implemented as IP table rules in the current stage. It gets intercepted by NSX, and NSX actually translate that into access to your system in a way that is protected by NSX. On the NSX Edge side of things, which is your entry point, this is extremely important because those are your ACLs to access the entire platform, right? That's the one that defines what can you access from the outside in. And typically, NSX Edge has also the capability of doing SSL termination right there. So you can do the SSL termination in Edge and then pass the traffic unencrypted underneath and treat essentially the entire platform like a virtual appliance. And that actually makes the deployments much easier. Particularly if you also enable NSX Edge, not only for SSL termination, but you also enable it for NATing out. If you NAT it out, basically all your entire platform is going to be under RFC 1918 addressing space, and you can install many foundations of your platform, and they're all going to look exactly alike. So you always know that the 192.168.10.1 is a Go router, for example. If you ever have a problem and you see the logs, you know that's a Go router causing the problem. Right? So it's easier to deploy a cookie cutter approach, but then you have to obviously deal with the NATing, and NSX Edge takes care of the NATing. NSX Edge will also take care of the outbound rule to external services. There's obviously physical services that you typically run, say in a mainframe. It's still very common to find mainframes out there, DB2 databases or large Oracle databases out there. You want to have access from your applications against those services, so somebody needs to broker the access to that. Somebody needs to set the rules. Can the platform access those services? In some cases, when you have a platform for development and a platform for production, you want to access different databases. You don't want them to access the same. Sometimes you have fake databases with fake personal data, right, to access, to do your development process. And then when the application gets promoted to production, they deal with real, actual customer data, right? These are different ways to do the application design here. The other best practice that we have here is to set up your DLR, or distributed logical router, which is the capability that NSX provides to set up an OSPF network up there. Why do you want to do this? Because if you don't, you're limited to the 10 interface limit that the NSX Edge has. NSX Edge is essentially a VM, and a VM is limited in the virtual hardware version to 10 interfaces maximum. If you want to break down that limitation, you leverage the fact that you have a DLR. In addition to that, this is going to distribute better the traffic east-west, right, within your data center. It's not going to create a tromboning effect where everything is north-south, right? It's going to be a little bit more efficient in that sense. And there's also this concept of isolation segments, which is a relatively new concept in the system, in which now you can say that you want to select a special group of cells and a special group of routers to be on a specific segment, let's say a specific pool or resource pool or a specific cluster within ESX. Those systems actually will allow you to do that in order for you to create, for example, high security applications that will only land in that particular cluster that you have. Or let's say that cluster has SSD access, so the system is much faster for I/O, for example, right? So there's a number of constraints that you can create around that system to make it faster for that purpose. So those are isolation segments, and you can create as many of them as you want if you have a DLR here. You don't have a limitation anymore on the number of interfaces. So every time the Bosch creates a new job now, it's going to populate automatically one of these security groups, and you can actually go behind scenes and add rules to those security groups. And this is an extremely powerful construct, because NSX, as you know, security groups in NSX, they're not your AWS security group, which are extremely basic and simplistic. These are much more robust type of entities, objects. You can even do service chaining with them. I mean, you can send traffic out to a Palo Alto Networks device, for example, without the knowledge of anything in PCF. This is all completely transparent to PCF, right? So you have the capability of configuring all this separately, so your security people can actually configure this outside the realm of the PCF operator, right? This is very, very powerful. Of course, you got to be careful. You can shoot yourself in the foot very easily. If you put a rule that starts blocking internal communication within the platform, then it's on you, right? So this is what we call true microsegmentation, right? Microsegmentation will be applied to each VNIC of all the VMs, and they will all be controlled by a single control plane by NSX. That's the idea. So for example, if an application needs to talk to an isolation segment that is in another side, it just can go out and be allowed to do that, or be denied to do that, if you choose to do so, depending on what's the workflow that you particularly want. Now, everything is going to be, again, using RFC 1918 for repeatability. It makes it really easy going forward to create repeatable environments that you can actually create cookie-cutter approaches. We actually have already pipelines, concourse pipelines, that will actually deploy platforms. Literally, all you got to fill is a little YAML file. Well, it's not that little, but yeah. But it's it's a YAML file. You just fill it up, right? And literally, go for coffee. 2.5 hours later, you have a platform. Just like that. I mean, and you can do that repeatable approach, as many as you need. So essentially, from the operator perspective, your network design should really consider this, again, this pipeline model. And check it out, actually, the tool that we keep talking about here, and it has this little blue circle here. It's called Concourse. You can actually go and check it out yourselves in the website called concourse.ci, which we're really lucky to get that domain, actually. It's very fun. So go and check it out. It's open source as well. You can download it, use it for anything. I'm actually controlling an irrigation system with that thing now. It's pretty fun. So you basically inject your little YAML file, and you can create as many platforms as you need. And from then on, the platform itself becomes a cookie-cutter approach. We have customers with running literally as many as 22 platforms, and they're all repeatable with this model in particular. Again, we're not promoting platform sprawl. I mean, we don't really like the idea. The platform is, in general, is intrinsically multi-tenant. However, many times you find situations where, for regulation purposes, or simply because the security teams are super strict, they will not let you carve out logically the platform. They will force you to put them in separate spaces and so on. If that's the case, that's how you do it, because it's going to solve your life much easier. It's going to be nothing manual. It's all automatically controlled. You can even check this pipeline code into a Git repo and verify versions and make sure it's consistent all the times, right? In addition to that, we were mentioning that you have security groups. The security groups will allow you to access proper services. Security groups look like this. These are very simple firewall type rules that are expressed in a little JSON file. It's very, very simplistic. They're all outbound rules because, as we said before, there's no inbound requirements here. All the inbound in Cloud Foundry comes from a single place, which is the load balancer. So all the rules are outbound. You're saying, can my space access that database? For example, the .10, yes. The 11.10, no, right? The 192.168.11.10, no. So I can specify with my security group with a single command, which is actually quite simple. They don't need to know, the developer doesn't need to know anything complex about how is that being implemented. This is extremely simple to set up. In addition to that, we now have the capability of doing container-to-container networking without going around to the load balancer, using specifically a Flannel version today, kind of modified version of Flannel that we call Silk. And we're actually doing the development right now for doing the NSX-T integration. The next generation NSX transformers, that is coming very shortly, actually. The integration is going to allow you to do this granularity that we're talking about down to the container, down to the app level. So you're going to be able to specify rules per app or even per container ID. So much, much lower level. And the developer only sees this very simple interface. All they see is, for example, allow access, source application, destination application, protocol port. Super simple. They don't need to understand a lot of firewall rules. All they need to do is say, what do they want? Do they want their application to talk to this other application? Fine. It doesn't have to go around to the load balancer again. It just needs to go directly to that one. And this is the mechanism that they currently use. And bear in mind that these apps can actually have any number of instances, right? That's one of the typical concepts within Cloud Foundry. An app can have 1,000 instances of that app. And the rules are exactly the same. They don't change, right? They're exactly the same semantics. We're using the CNI interface here, which is a low-level JSON-based type interface to express the information. The application receives information, in this case from NSX-T. It receives information about their IP information every time that the container gets created. It's part of the container create workflow. So all this, again, can be declared in a CI/CD process, and all this can be automated. Absolutely everything here.
Yeah. What about PKS?
Yeah. What about it?
You guys like want to stand up, take, stretch your arms, and get a glass of water or something from all this stuff we're throwing at you? I'm only going to go over one slide. We went over like 20-something slides. So networking in Kubernetes is far less complex. Even though this image might be a little scary, I'll go over it with you. There's really two key networks that you consider yourself with per Kubernetes cluster. Now, understand that you're typically going to have more than one Kubernetes cluster in a production environment because you might have one cluster per team or per set of business services. You're going to have more Kubernetes clusters than you will PCF clusters. Excuse me. You have one key network, which is going to be a control plane network. So that's what this outer green box is, and that's where all of your master nodes and your etcd nodes and your worker nodes, they're all going to share a common IP address. Let's just take, for example, this 10.1.0/24 network. They all have to communicate with each other. When you actually run a pod, though, like you see these pods here, like dashboard or mypod.2, remember that pod concept, that those are the containers? Typically what happens, and this is how we do it by default in PKS, is you'll have a secondary network that will be an overlay network, right? That'll either typically be like a VXLAN that'll ride on top of this 10.0.1. It'll be a separate subnet, and by default, all of the workers will be running something called a kube proxy. They'll be able to route amongst themselves. They'll be able to go east-west all they want. On that overlay network. Everybody will be routable on that subnet. There will be no natting. Like, we didn't really go over that in detail on the PCF side, but there's a lot of natting in PCF. And it actually makes it a lot simpler. And then the way that you ingress, in other words, if I'm going to if I had a web app running in here and I wanted to take an HTTP request, or if I had a microservice that has a REST API, is you implement a service. Remember earlier in the blue box I had, hey, you put up a service and you have to define what type it is for ingress. That's what this orange box is here. You define a type of service, and these are probably three of the most popular types of services that you would have a developer define to use. Ingress, the ingress service actually kind of creates a little load balancer inside of the Kubernetes cluster for you, and does some of that layer 7 type routing that PCF does. Load balancer is actually a plugin that you could have Kubernetes interact with an external load balancer, or you can use node port, which just opens up a TCP port. So that you would actually create a service, or that's what this little box here for is external service gateway, or you would install the kube proxy on another VM and have it actually join this overlay network, this ring, and then have it be able to communicate with any of the services on the network. So by default, a Kubernetes deployment is intended to be a microservices architecture. It's dependent for services to talk to each other, and then you have to manually wire up, well, I say manually, you automate it, but you have to make the decision to wire external access or external ingress via a service, or via actually putting a kube proxy onto something like another load balancer and making it a member of the cluster. It's a lot simpler. You don't have to worry about network space.
Well, no, though, on the kube proxies, those are not your typical off-the-shelf like OSS kube proxies that you find. These are special sauce kube proxies that have actually constructs within an SXT inside, which are really very advanced. They get advanced logic behind that.
Yeah, these components, especially the kube proxy, and there'll be some extra components for NSXT integration here, but the concept is you really have a core management network for your Kubernetes cluster and an overlay network where all of your containers are talking, and it's up to you to figure out how you're going to wire that ingress access in. So it's a lot more simplistic model, but because it's more simplistic doesn't mean it's better. It allows more choice to the developer and to the operator how they're going to route things in. PCF's making those decisions for you, which is why we have to do so much architecture around PCF. In addition, PCF also is, by its nature, intended to be more multi-tenant than a Kubernetes cluster is. So monitoring and logging. How much time do we have? Yeah, I think we might actually make this. So we're trying to give you guys best practices whether you're running Kubernetes or whether you're running PCF. Do not forget about monitoring and logging. The developers are just as keen on that stuff as the operators are. So there's certain things that you need to do whenever you're running a platform and you're running a cloud-native platform and giving an API to your developers. One of them is you need to help them work out how they're going to log their app traffic. And you need to do this securely sometimes because some app logs have secured information. Like it's not all just, hey, start, run, spring. There's sometimes injected information that you want to make sure that information is kept secure. So you need to sometimes work with your developers to make sure that you give them a self-service access to their apps logs, which you can see there's many ways a developer can do that. With Cloud Foundry, they can just run the CF logs command and tie in through the logregator, or there's a component called PCF metrics that kind of pushes some in. But the key thing I'm going to call out here is this vRealize log insight. What you want to do is you want to make sure you provide some method that you can shuffle off the long-term logs of your applications in a secure manner. Because Cloud Foundry doesn't keep all of that log information in it. It's very much an ephemeral thing. So you want to make sure that you're wiring your logregator to actually store that log information external so that the developers can access it and also the operators can access it and the auditors can access it if you're going through a compliance audit and have to look at that. In addition, developers need to instrument performance monitoring, not just app logging, but they need to be able to see how well their apps are performing. So another thing you should consider as an operator is, should I give my developers a self-service way that they can consume an APM tool, application performance monitoring? And this is different than what a vSphere admin would be used to, looking at like 4 basic food groups in the vSphere infrastructure. This is things like actually having a developer code in a query trace to see how long a query takes or what different stages of a query might take so that they can instrument specific performance for their application, or maybe even Java specific things like heap size, that kind of stuff. Those are things that operators typically don't get involved in because remember, we're like keeping the platform up and running. We don't have the knowledge in most cases of what's going on in the application that the app teams need to have that. So we have wavefront integration with Cloud Foundry and with Kubernetes that we can extend application performance monitoring into the developer space, which is hugely important. And considering offering that up as a service for policy generation is a key thing. Also, the operator does need to look at the infrastructure. Developers don't care about the infrastructure because they're up here accessing spaces and orgs, but operators surely do. So we have some integration with Blumador, with vRealize Operations and vRealize Log Insight, where we can combine a consistent view across what's happening in the infrastructure, what's happening in the platform, and also what's happening at the container level. We don't need to go inside the container to find out what those app-specific metrics are, but the operator should at least know which apps are running on which VMs, so that in the end, if I'm running the physical congestion on my VM side or virtual congestion, that I should be able to find that out with my tools. And so the integrations we have with VRops and vRealize Log Insight do that for us. What about PKS? PKS is a little different architecturally. PKS offers, or Kubernetes I should say, because this is necessarily like a PKS specific thing. PKS offers you a lot of different ways to get your logs out too, but the key thing to point out here is that we can also ingest all of those logs from the applications and the platform out to vRealize Log Insight as well. What we're probably going to be looking at doing with PKS is having a predetermined daemon set running with a fluent D to log out to vRealize Log Insight so that we can make sure that operators can see all of the logs from all the applications inside of the Kubernetes cluster. But it still doesn't mean that this covers Kubernetes. You still, just like in the previous view, you still have to make sure that you're looking at logs, information, and metrics from your physical infrastructure. So Wavefront also, we focused in on what the developer would consume from Wavefront. The platform operator can also use Wavefront as well, because you're going to be getting, you see here in this basic architecture, you're going to be getting metrics from each of those Kubernetes clusters from cAdvisor that are going to be aggregated through an open source project called Heapster, and then Heapster can push those to Wavefront. So an operator can also benefit from Wavefront as well, because depending on which view you want to have a near real-time view, you want to have a long-term deterministic view, VROPS or Wavefront might be either two tools combined or one tool better than the other based on your use case and your alerting mechanism.
Besides, don't forget that Wavefront is actually a SaaS tool, so you can use it in some specific cases that is SaaS-based, right?
Yeah. Right. And we can see here, this is just an imagery view of vRealize operations, showing us some information about our pods as well, because vRealize also integrates with Kubernetes and PKS, so that, if you guys are, raise your hands if you're vRealize shops, if you run VROPS or vRealize Log Insight.
Mm-hmm. A few?
Yeah,
several.
Fair amount. There's a lot of good integration here for both Cloud Foundry and Kubernetes that's available. It's GA. It's not stuff that we're thinking about doing it. It's there. So last topic we'll go over, and then we'll actually have time for questions. I mentioned this before, platform as code, earlier on. And the concept there is, if you guys attended the other talk that we had, we broached the subject of site reliability engineering. If you're a vSphere admin today and your enterprise or your company is looking at running cloud native applications, they're going to be deploying a platform like Kubernetes or like Cloud Foundry, whether it's VMware's or some other third parties. And they're likely going to be looking for a resource to help become a platform operator. A platform operator should be that guy that's entitled like your traditional VI admin, your traditional infrastructure admin, your network admin. In other words, he knows where all the keys are, he knows what the physical architecture is, and he's entitled to make changes. But he should also be like a developer in that he doesn't want to have to go and build a script that's not portable or write a document on how to do a deployment process. He wants to treat that like it's code, like it's something structured, like an API or a front end like Terraform or using Bosch in this case. And so Bosch is the tool that we use to deploy both PKS and PCF. And the intent is that all that declarative information about what happens goes into these Bosch deployment manifests. Bosch deploys both Cloud Foundry and PKS by combining a release, which is what Kubo is, if you guys have seen one of my other talks, the Kubo release, or the PCF ERT releases, and a stem cell, which is a blank VM. And the manifest tells Bosch what to do with that blank VM image and all that software so that you get a deployment in the end. So if that's the case, then I can wire a pipeline into that. I can treat it just like a developer treats a piece of code. I just have to keep making sure that I manipulate that YAML to make sure that it's defining what the end state of my Cloud Foundry and my PKS deployment should be. So it's declarative. I can tell that in the YAML. I can say, hey, I also want to drive NSX. I want to make sure that I have an NSX edge VIP, the third VIP, and I want to make sure that it has this IP address information. Feed that in, if you want to see the animation. YAML goes into the operator, checks it into Git, goes to the pipeline runs it and makes it happen in reality. So it's very much an iterative CI/CD process, just like your developers are going to be doing with their applications. The operator begins to take the same process with his platform, so he can deploy his platform anywhere in the same way. He can declare it. He can check in. Another benefit of this is checking all those commits into the Git repo. Also means you get a little bit of auditing of who's making what changes to your production environments. And so this is a pattern that we've done with a lot of PCF customers, and we're likely to do with a lot of PKS customers.
Well, one note on this, I think the important concept here is that the stem cell, which is basically the VM image, is not something that you provide. It's something that we, Pivotal/VMware, provide, and it's curated by us. So you remove the operating system out of the picture here. You don't have to worry about patching OSs. That's done by the third party, in this case ourselves.
Yeah. And the reason you want to do this is I need to scale. I need multiple foundations. I need to repair. One of them's failed, and I need to recover it. So let me I mean, commit into the pipeline and say, hey, go ahead and recover this one, or I need to rotate credentials, I need to rotate certificates. When you start making your entire platform and your entire infrastructure code-driven, repeatable, and portable, it's important to say portable too. That means it's something, because you can script automate a lot of things or wire in a lot of custom automation that becomes difficult when you want to move it from environment to environment. If you can make that ubiquitous across environments, which is what these tools do, then that's something that makes it so much more powerful. The guy that develops it doesn't have to always live with it and take the call at 2 in the morning to make sure the automation's working. Another concept, how much time we have?
None.
Yeah, none. This is a good way to do patching. Patching at, you can do patching at any layer. Remember the Cloud Foundry thing? Because it composes the image, it's much easier to apply CVE patches like Heartbleed, which hundreds of, I say hundreds, thousands of AIs were patched and made healthy from Heartbleed just by an operator doing one thing in each of our customer sites because of the way that PCF composes images. And it's similar with Kubernetes, but because you don't compose the image in the platform, you got to bug your developers and you got to make sure that you have a registry that checks to make sure if there's CVEs, which Harbor does. It's a good benefit to Harbor and a good thing that's included.
Claire, right?
Yep, ClarityB. And that, we're going to go ahead and roll some questions because we threw a lot at you guys, and we do have 5 minutes for questions. We apologize. The intent was that when we're done, and you have some referenceable material that you can use after the event, say, I wonder what they were talking about how to do this with Kubernetes or PCF. So, you guys have...
This is being recorded, so if you can talk to the microphone, that would be great, so we'll know. Anybody has any questions? Please. Just give us a second. Sorry. So I want to make sure that you guys get recorded for the posterity.
Yeah, perhaps 2 questions. First one is the Bosch layer to deploy PKS. Is that at the moment only vSphere? Are there plans to also support deploying to other platforms? And the second, what are best practices for a service broker to connect to a Kubernetes environment?
So I'll answer the first question. So the question is the Bosch CPI only vSphere? In PKS, is it only vSphere? Yeah. Right? Is that the question?
Yeah.
So when we release PKS in the December timeframe, I'm trying to roll back to the image, but I just answered here. It will be the vSphere CPI, but it will be available on a VMC, which is VMware Cloud, our implementation of vSphere on AWS as well. That doesn't mean we don't intend to offer PKS more publicly with other CPIs because Bosch, the underlying technology, does have multiple CPIs. But VMware's PKS or pivotal VMware PKS that we're going to announce or release in December is going to be the vSphere CPI. And the second question, I've already forgotten.
Yeah, so in the PKS platform, are there any best practices or recommendations to connect to services, like a service broker, for instance, for stateful things, to connect to databases? Or
It's a best practice to have a service broker or a service mesh. We are actively looking at including a service mesh at some point. I don't know if we'll have it at release. Probably not, because you got to release MVP. But the Open Service Broker API, which again I'd have to float through the images again. You saw we had the GCP Service Broker. So there's going to be the Open Service Broker API, which is something that Pivotal has actually contributed back to the Cloud Native Computing Foundation, and it's going to be included upstream inside of Kubernetes. So we're going to have the framework there to wire up services externally everywhere. So it's a best practice. It is most definitely a best practice that you want services to be consumed via the API panel. You don't want to have either operators doing manual processes or ticket-driven processes to provision the services. So that's going to be eventually roadmap into a broad ecosystem inside of PKS, but we may not have all that completely delivered in the December timeframe.
Yeah. Okay, thanks.
Does that answer your question?
Yeah, perfect.
Anybody else? Going once? Going twice?
So raise your hands if this was like, what are these guys talking about? Come on. Yeah, so we hope you guys got something out of this. And again, a lot of this is for reference information for take home for you guys. You're all operators. These are important concepts because as your companies and enterprises are looking at containers, they're going to be looking to you guys to assume that platform operator role. And it's all about knowing what are the right things, like what are the right network security things, container aware networking, monitoring and logging, external services, how do we, they're all going to be depending on you guys to build that stuff. And we're going to help you. That's what we're building these products for, but it's where things are moving.
Thank you.
Thank you.